Okay, welcome back. Let's go into Desmos and see if we got this. I'm going to hit these X's. Now I'm going to type in AX squared. Add that slider in. We've got this one. And now we can slide it back and forth to see what it's doing. And it looks like this is a dilation, just like we thought it would be, because we're multiplying it. It's dilating it, stretching and squeezing it. Now for dilations, I'm going to have you start with a number bigger than 1. So pick any number bigger than 1. Notice for this one, the bigger you go, the skinnier your parabola gets, kind of like stretching that rubber band. So when we stretch that rubber band, it gets skinnier and skinnier. And this makes sense. If we're multiplying by 7.3, then it stretches even more. Now pick a number between 0 and 1. I got this one. 0.1 for me. Now it's stretching that graph out. It's like laying that rubber band flat. So when you've got a fraction between 0 and 1, it flattens. The higher you multiply it, the more it squeezes. So we're going to go over here. If A is between 0 and 1, then we've got a flat graph. If it's greater than 1, then we've got a skinny graph. You might start to be starting to notice some patterns here. So let's look at this inside one. And without even graphing on Desmos, think about these patterns. So if B is from 0 to 1, and if B is greater than 1. Now, this one is on the inside of your equation, not the outside. So it's going to be the same thing here, where it's going to be counterintuitive what you think it should be. From 0 to 1 will be your bigger stretch, and greater than 1 will be your fatter stretch. Now, one other thing to note, and this is kind of hard to see with a parabola, because with a parabola, if you stretch it this way versus if you stretch it this way, it kind of looks the same. It's a little easier to see with other graphs. But A, when it's on the outside, is stretching your graph up and down. E on the inside is stretching it side to side. So those are our next ones. Last ones are some reflections. Let's do square root of x. And we're going to have a negative on the outside of our root. So negative root x, and then a negative on the inside of our root. And then see what this does. So back to Desmos we go. Let's plot our original equation. If you want to do square root, you type SQRT, and it transforms it into a square root. So there's our original. Now I put a negative on the outside, and I get the green one. And then I'm going to put a negative on the inside, and I get the purple one. So if I compare the blue and the green one, looks like this is reflecting it up and down across the x-axis. So if my negative is outside, then it's reflecting up and down. If negative is inside, that's the blue and the purple, now it's reflecting it side to side or across the axis. Now these are a lot of different rules to memorize. Let's go to the top of the next page and summarize this. We can summarize all of this in 2 simple rules. You have rules when you have numbers on the outside function. So outside square, outside your square root, outside your sine, outside your logarithm, that kind of stuff. Or you have things when it's on the inside of your function. Those are our 2 rules. So let's clarify this. If it's on the outside, it's always going to move things vertically. Whether it's shifting vertically, stretching vertically, reflecting vertically, that, and it's all be the same what we think it should be. So up is positive, down is negative. A fraction makes it smaller, a whole number makes it bigger. Inside moves things left to right, and this opposite. So a negative actually moves right, a positive moves left, a fraction makes it big, a whole number makes it smaller. It's counterintuitive what you think. And if you can remember those rules, you can do all of this. In the next video, we'll start to practice some examples.